Hello, everybody. Welcome to, I'm Renee Magyar with West Multnomah Soil and Water Conservation District. Welcome to tonight's session of Soil School on the 4 principles of soil health. We're hosting a series with Tualatin Soil and Water Conservation District. And in case you aren't familiar with our organizations, West Multnomah's mission is to provide resources, information, and expertise to inspire people to actively improve air and water quality, fish and wildlife habitat, and soil health. We serve residents of Western Multnomah County, Southern Island, and a portion of native plants, wildlife habitat restoration, and school gardens. Tualatin Soil and Water Conservation District's mission is to create a sustainable, productive, and healthy environment for the Washington County, Oregon community. They serve residents of the by providing advice about natural resource conservation and financial assistance for conservation projects. So I have a few housekeeping tips tonight. We're recording all of the sessions and they will be available on Tualatin's YouTube channel about a week after the session. You can find a link for that if you signed up for this, and I'll put it in the chat towards the as we get rolling here. Tonight's presentation will go until 6:50. Cory will be presenting until 6:50, and then we'll have 10 minutes of Q&A after that. Please put your questions in monitoring Q&A, but not chat so much. Cory, though, I think is going to be doing a little bit of introduction there. And also, when you're in the Q&A window, there is a thumbs up icon, so you can upvote a question if there's something that you want to be answered. Then click the thumb, and then we'll make sure that we answer that question. I am pleased to introduce today's presenter. Cory Owens is the State Soil Scientist and Soil Health Coordinator for USDA Natural Resources Conservation Service based out of Portland. She leads the Technical Soil Services Program across the state, including helping farmers, ranchers, and foresters learn how a healthy soil can help them. Cory completed her undergraduate work in crop and soil science at Oregon State University and her graduate work at the University of California, Davis, earning a master's in soil science. Her favorite soil is Amity. So now, Cory, I will turn it over to you to introduce us to the 4 principles of soil health.
Hi, everybody. Welcome to your Thursday night that you've decided to learn about soil, which is amazing. We were chatting before we started. This is my 4th soil school, so super excited to be here. It does not take much to get me excited to talk to any group of people about soil health. So I'm just going to launch into it. I've got a lot of information I want to pack into these 50 minutes, and I want to be able to have a chance to answer some questions. So with that, the presentation is about the 4 principles of soil health. Well, we're going to start with the grand reveal. Here are the 4 principles of soil health. Soil health principles to support high functioning soils. We want to maximize living roots, maximize diversity, minimize disturbance, and maximize cover. You could just stop there. Those are the principles. That's all you need to know, right? Nope. I'm going to spend the next 50 minutes explaining the why behind why we want to think about these principles, how they impact your management decisions, and then go in depth about how you actually apply the principles. But I wanted to start this presentation with, here they are. These are the principles. This is the whole reason we're going to be chatting today. And we're going to spend half the time talking about why and the other half the time talking about how. So, soil function. What do I mean by soil function? Well, there's a pretty big question. What do we want soil to do for us? Many of you I know listen to James Cassidy give his presentation about soils, and you understand more than you ever wanted to know, or maybe you did want to know all of that about what soil is. I want to think about now, what does soil do? So of the 56 people in there, I would be thrilled if at least 3 of you would open your chat window and give me an idea of what one thing you would want soil to do for you. We're going to wait. This is a test. Who knows how to use their chat to be able to answer the question? All right, we want it to produce life. We want carbon sequestration. This is great. All right, one more. Feed our plants, grow veggies, grow delicious tomatoes, of course, native plants. You want to stay alive, I want to stay alive. Awesome. Create habitat, support life, ecosystem. You guys are there, man. You've heard about soil. You heard about soil functions. Well, here's kind of like the list that I'm going to go over of what we want soil to do. As you said, we want to support productive plants. We want soil to be stable and resist erosion. We want soil to be efficient at cycling nutrients internally. We want all of that work we put into replenishing the soil. We want those nutrients to get into the plants. We want water to get into the soil quickly on a rain event or an irrigation system. We then want that water to be able to drain out of the soil if we're in an agronomic setting and without drowning the roots. But then we want it to be able to store the water. So it's kind of pretty demanding of us. We want the water to go in, we want it to come out, but we want some of it to stay so it can grow the plants and feed the plants. We want our soils to be able to resist pests, pathogens, and disease. We want our soils to be able to help our plants go through stressful events like a drought or a crazy storm or something. So there's lots of ways and things that we want soil to do, and the way it does it is biology. So if any of you have ever looked at a soil survey, put in the chat if you've ever seen a soil survey. I've used web soil survey. You might have if James got to that part of his talk when he was talking about. So soil surveys are these amazing resources that for the last, 7,500 years have been putting together all of this body of information about where soils are and what they look like. And they're full of physical, chemical, and engineering properties, because biology is really hard to pin down and it's so dynamic. When we talk about soil function, it's not just where soil is and what it looks like it looks, it's what the soil does. And that is all mitigated through biology. Now, what is this? Okay, biology, great. Well, what does that mean? Biology is a pretty broad term. Well, I am talking about the soil food web. This is my newest favorite picture of the soil food web. This is from Xerces Society publication. Xerces is all about pollinators and insects. That's why you kind of see that highlighted here. But what you have here is this absolutely gorgeous picture of, everything that's going into soil. You've got these beautiful root systems, and you've got these worm channels, and you see all these arthropods, but then you see all those little circles, those are blown up of fungi and protozoa and amoebas and bacteria, nematodes, and then you have living roots, you've got mushrooms, you've got dead plant material. That is the soil food web. All of those different trophic levels of the ecosystem kind of contained in this space. And what drives that soil food web? Sunshine, the beautiful sunshine that we had today and we have had for the last few days, which has been amazing. So that sun, that big ball of flame in our solar system at the center, is sending out energy. And plants do the wonderful, convenient thing called photosynthesis, is capturing that sun's energy. It's taking carbon dioxide and it's taking, CO2 and water, all that stuff, and it's going through photosynthesis and it's building their plant structures with that carbon. It's converting that carbon into plant structures, leaves, stems, flowers, and then roots. But not all of that carbon makes plant parts. They actually, in plants, they pump a lot of that carbon out into the soil ecosystem. Depending on the plant, it could be 25%, 30%, or less, or more of the carbon that it's generating through photosynthesis is actually going into the soil. Why in the world would a plant put that much energy out of its body into the soil? Well, that's because they know those plants are developed in these ecosystems where that energy goes into the soil and it drives all these different things. Microorganisms then capture that energy through feeding off the exudates of the roots, and then, different things eat those, and it's this whole kill or be killed, consuming, and then dying and living and getting born, all this kind of stuff going repeated. So you get this really robust and complex, huge system. Now, who's in there? Where we can think about all that diversity of a soil food web in kind of three big buckets. We've got our ecosystem engineers. These are the guys you can see. These are the roots, the earthworms, invertebrates, caterpillars. These are the guys that are, from this picture, that you can actually see making the tunnels and the pore system and shaping and pushing and, you know, forming these aggregates. And they're also the redistribution system. So when that leaf dies and all that carbon's just sitting in that one, like, you know, 5 by 5 centimeter spot, no, that worm's going to grab it, that, you know, shredder, that beetle's going to grab it, it's going to break it up, and it's going to walk a foot away. And that foot's like a marathon for that little beetle, right? And then it's going to drop some of that energy there, and it's going to spread all that out and mix it all up. We also have the biochemical engineers. So these are all the guys in that soil food web that you can't see. The microbes, the bacteria, the archaea, the fungi, the protozoa. You know, in 1 tablespoon of soil, there are more microorganisms than there are people on the planet. And if you think about holding a handful of soil, you know, you're holding worlds and worlds full of microorganisms. And what are these guys doing? These guys are the biochemical engineers. They are mitigating all the chemical transformations. They're cycling the nutrients. They're regulating energy, because that sunlight hitting that leaf going into the exudate is the first thing that's going to hit is a bacteria. All right, and that bacteria is going to capture that energy and it's going to do its life cycle. And the other thing that's great about these biochemical engineers is that when there's a lot of them and there's a lot of diversity of them, it's survival of the fittest. And so you don't get one particular population that's going to be able to spike. And so you were able to have this protection from plant stress or predators and stuff because you have this robust diversity. Now, the next group of things are these biological regulators. These are the guys in between the big stuff you can see and the little stuff you can't see, and kind of on the fringes of both. So these are the guys that regulate populations of other organisms and they mineralize nutrients. So the protozoas, when you remember high school biology, you looked in the microscope at the pond water, you saw something swimming around, that's a protozoa. And they're really small invertebrates that look like monsters, or the teeny tiny ones that you can kind of see, like the moths, the mites, the springtails. But one of the things that these guys do is they mineralize nutrients. You're like, okay, great. Well, how does a protozoa swimming in the soil water film mineralize nutrients? Well, what does a protozoa eat? A protozoa eats a bacteria. What is a bacteria? It's a single-celled organism full of stuff in its single-cell body. What is that stuff made out of? It's made out of calcium, nitrogen, phosphorus, sulfur, little molybdenum, you know, selenium, boron. And when you think about what it takes to grow plants, what are all those things I just said? Essential plant nutrients. Those are in the body of those bacteria. They're bags of fertilizer upon the billions and trillions and gajillions. And how do you get that fertilizer out of the bacteria? You got to get a protozoa to chop it, rip its head open, spill its guts, get that stuff all out into the soil solution. Then it gets onto that cation exchange capacity of those silicate clays, which I know if you listen to James talk about, you got really good at knowing about those silicate clays. They'll capture onto those, and then that can get absorbed by those plant roots. So you've got to have all these different functions within the soil food web, because we have to think of soil as habitat. And this slide hopefully came up with James, that soil is habitat. If you take one thing away from the 50 minutes, 60 minutes that we get to spend together today, that you've chosen to spend your Thursday evening thinking about soils, I want you to walk away knowing that soil is habitat. Soil is an ecosystem. So that the next time you're doing a social distance garage visit, or you're Zooming with your family in Arkansas, I don't know, and they're like, hey, what do you guys do? And you say, hey, I spend the next 15 minutes talking to them about how soil is a habitat. And it's not just one habitat. We think about biomes, the desert, the jungle, you know, the Pacific Northwest boreal, you know, forest or whatever. In soil, like this picture is teeny tiny, it's 100 microns, right? You can see the root hairs in this picture. You can see the fungal mycelium in this picture. That's the stuff wrapping around the root. And the spiky things coming off the root are the root hairs. Then you have pieces of sand and silt and clay, and you've got that mite who looks like Godzilla. And then you have those pore spaces, right? You could be standing on, and I don't know if you can see my pointer, but you could be standing on the bottom of that hole in the middle, looking up to an ocean. And that ocean is above you, and that's an aquatic ecosystem because gravity doesn't work in soils the same way. Pore space and capillary forces hold water in nooks and crannies. And that ocean could be completely unique and hold a trillion microorganisms that don't exist anywhere else, right? And then you turn around and there's a lake next to you. So soil is this robust terrestrial and aquatic habitat that is existing in all these pore spaces with all these microorganisms and biological organisms, teeny tiny stuff, big stuff, that are all existing and functioning and living and dying and eating and pooping and having babies and killing babies, and then roots go down there and then it rains and it floods. So habitat is so critical to soil function. And the way that we understand habitat is through aggregates. And if you're managing for soil aggregates, if you're managing for habitat, then you get these wonderful things that soils will do for you. It'll store water, it'll influence the pH, it gives you that nutrient storage happening on the cation exchange capacity sites and within the cation capacity sites of the organic matter complexes and in the bodies of the microorganisms. You get that soil structure that you need. That's the bones and the infrastructure upholding all that together. All those kind of things happen based on how you're managing that soil. And how you manage soil comes completely down to aggregates. Aggregates are it. Aggregates are the synthesis of a soil's biological, chemical, and physical properties. How stable your aggregates are is, at the end of the day, the most important thing. So I'm going to stop sharing my screen so that I can give you guys a demonstration. And that demonstration is all about, why do I want to think about these soil health principles? What is Cory doing? She's talking really loud and she's very excited about maximizing living roots, minimizing disturbance, maximizing cover, and maximizing diversity. And she just told me that I need to have a healthy and robust functioning soil food web so that they can build their ecosystem and their habitat. And they need aggregates. Well, how does this all fit together? So I'm gonna stop my screen share. So now hopefully you just see me and it's big. I'm gonna move this a little bit. I have water in little baskets. These are cauldrons. They're actually bigger than you can see on the screen. I have 2 soil clods. These are Willamette silt loams that come from the Plant Materials Center in Corvallis, Oregon. I don't know which one is which, but I am just going to drop them in the water. Well, gently place them on their baskets in the water. Hopefully, oh, I did this the other day and I needed. Hopefully you guys can see what's happening. Can someone write in the chat and tell me? Some of the people are having a hard time hearing. Okay. I apologize for that. Hopefully the recording will come through. As this demo is going, I'm going to pop in my headphones and see if that's better. Hello, test audio. Okay, hopefully you guys can hear me better. All right, someone is actually paying attention. One of these is dissolving faster. Okay, so I'm gonna say one is dissolving, one is not. Those are great observations. It's not so much that it's dissolving, it's more that, and maybe you guys can see on this, these little air bubbles popping up. Do you guys see these air bubbles popping up? What's happening is these are dry soil clods and water is rushing into that pore space. And soils that have strong, stable aggregation, and we're gonna dive deep in aggregation. You guys would be like, whoa, that was crazy. The soils that have strong, stable aggregation can resist the force of the water rushing into those pores and pushing against the side of the soil. And when soils are not strong and they're not stable and they don't have vibrant and robust ecosystems, then they shatter. So it's not so much it's dissolving as the soil is shattering based on the force of the water. So you can see here, there is nothing. This is just a manila envelope and there's nothing coming down here, and this is cloudy and brown. So the goal from a management perspective is that we want our soil aggregates to stay stable. And we're going to use our soil health principles to be able to get them to be stable. So I'm going to move these back. I'm going to reshare my screen, and we're going to dive deeper than you ever wanted to know about how soil aggregates form. Maybe you wanted to know. You did sign up today. Okay. I'm assuming everyone can see my screen now. I'm getting a message that says it's low audio quality. So Randy, if we have trouble again, can you, oh, it's not letting me bring up the chat. Just a second, everybody. There we go. If we have to change anything up, let me know on the audio quality. All right, so what are we going to do? We're going to dive deep into aggregates. This is a schematic of how aggregates go, how they form. And so I'm going to kind of drill down into this. This is the full picture, going from primary particles at a chemical bond level all the way up to something the size of a grape nut. So at the smallest level of aggregate formation, at the primary particle, this is the individual silt and clay particles and those complex humus organic particles. You know, those have chemical bonds because they have positive and negative charges. So those are holding together on those chemical bond level. And then that's, you know, here you have those sheets of silicate clays and you have all the funky shaped clays. And then the next level up is when you have these mineral clay grains that are being held together and coated with microbial exudates and root exudates. I'd mentioned my root exudates because they're pumping stuff into the soil ecosystem, but the stuff they're pumping is sticky. And so it'll bind the mineral and the, you know, other dead organic matter into these, starting to bring these sub-micro aggregate particles together. And you see, even at the very fundamental level, there's still a lot of space in there. So if we go up to the next level of aggregate formation, we're talking about micro aggregates. So if you take, this is 0.3 millimeters. So if you think of a centimeter and 1 millimeter in that centimeter, and then one, and let's split that into 10, it's just 3 of those tenths of a millimeter. This is tiny. So this is stuff still that you're not going to be able to see very well with your human eye. And this is where you get mycorrhizal fungal hyphae that are enmeshing soil particles together, and they're taking those little bits. Okay, I'll stop moving around. Thank you. I get so excited. I'll stop. I'll sit very still, and I will no longer be an animated speaker. So when you get those enmeshment of the fungal hyphae, it's pushing those microaggregates together. And then the that green, bright green stuff that you're seeing, that are polysaccharides. That is the icky, sticky stuff that comes out of a microorganism, bacteria or a, you know, archaea or something that's just gooey. So they have to, they live on the surfaces of things, and so they stick to each other and they stick to the surfaces. And then of course, when they get their guts full by protozoa, that's leaky and sticky too. So you have all these things that come together. And then when you get to like the grape nut scale, 3 millimeters, then you have the stuff that you can see. The fungal hyphae that, you know, if you lift up a rock or you lift up a bark in a down tree in a forest hike, you see the white filaments. Those are the fungal hyphae. And then the roots actually start to hold all these things together into these macro aggregates. And then of course, you have, you know, all those macro aggregates get combined into those chunk size sections that you saw when I put them in the water. Now, of course, I'd be remiss if I didn't mention some of the physical and chemical factors that help with soil aggregation, drying and wetting, freeze thaw. Fire can kind of make soil come together or fall apart. And there's inorganic binding agents that you would see in the scenario. But for the most part, in soils that are being managed for agricultural productivity or pasture or grazing, we're interested in those organic ways in which soil gets held together. So why does this matter? Why is she just sending me this like deep dive into the microscopic bonding of silicate clays and organic matter with bacterial goo? Well, it all comes down to soil being habitat, and that is the primary level at which habitat forms. So you need this organic matter, you need the sun shining on those leaves, creating organic material that's getting pumped into soil, the detritus of those dead plants that are getting recycled by those ecosystem engineers. and biochemical regulators, right? So you need all those guys to be building this organic matter that's feeding the soil food web, that allows that soil food web through its life cycle to create these highly stable aggregates. I mean, this aggregate here, this one that's not messed up, this will stay this way for a month. Like, it's not going anywhere. They'll stay that way for longer than a month. I've had them in my office for a whole season, and even longer. Then I just, got to dump it out. So anyway, you want those really stable aggregates because those aggregates have all of that energy. Part of it is being used to build their house. And then when you get a functioning ecosystem, then you get soil functions. And you get soil functions, then you get all the things that we want soils to do for us. And this is a quote from the Soils 101 textbook. The formation and maintenance of a high degree of aggregation is one of the most difficult tasks of soil management, yet it is also one of the most important, such as the potent means of influencing ecosystem function. That's from the Nature and Properties of Soils. That was one sentence in a textbook this thick about how important. I will turn my video off, so hopefully my internet is good. All right. So it's one sentence in the textbook all about making sure that you focus on aggregation to create ecosystem function. And how you do that is via management. So now we're gonna get, this is all the why. Why is this important? Because we want our soils to be highly aggregated and not degraded. And most of the soils that people are working with now are degraded to some extent. So the more you till, the more you disturb, the more soil erosion you have. If you're not adding as sufficient residues or organic matter, then you get soil matter. Organic matter decreases, you get your aggregates break down, your surface becomes compacted, you get crust, you get more erosion by water and wind, you lose more organic matter, and you cycle down until eventually you really do have a decrease in yield, and because you have less water storage, less diversity of organisms, not enough nutrient cycling, and you get to this bottom baseline of hunger and malnutrition result, which sounds pretty devastating, and obviously is not the world that we currently live in Oregon. But all you have to do is Google soils and civilization if you wanted to add to your global bleakness, if the global pandemic and climate change are enough. Then Google soils and civilization, and you'll see that civilizations rise and fall about how well they take care of their soils. But there is hope. There is hope for all of us. There's hope that we can do a better job, and that's called the soil aggregation climb. So as you increase biological activity by applying those soil health principles, you will get more organic matter, you'll get improved nutrient cycling, and you won't be able to see all that stuff at first. But the more that you can do that, you will cross a threshold where you'll start to see better aggregation, improved soil structure, and with that comes improved water holding capacity, improved nutrient cycling, and you'll see these visible outcomes that can make a difference for efficiency of it. All right, so that was all of the why. Now here's the how. These soil health principles, how do we get good soil aggregation? You do that by feeding your soil and protecting your soil. And by soil, I mean your soil food web. I paused for a drink right there. So feeding our soil because we want diverse and continuous inputs of carbon because carbon is energy. We want to protect our soil because if the microorganisms have spent so much time building their habitat in the soil aggregates, we want that habitat to stay there. So what are we talking about when we're feeding our soil biota? We want this soil organisms to have a lot of diversity to break disease and pest cycles, to stimulate and change diversity below ground, to increase our soil organic matter, increase our nutrient cycling, enhance plant growth, increase predator and pollinator populations. We just want to add to the overall energy going into the system and diversity of the system. We want to protect our soil because we want to maintain those stable aggregates. We want to reduce erosion and reduce our runoff risk. We want to buffer against extreme temperatures. No organism likes to be in the blazing hot sun. We want to reduce evaporation because we want that moisture that we capture in the soil to stay there as long as possible to feed our plants. And then of course, we want to maintain our soil organic matter level. So we are going to dive deeper into these. Living roots, maximize living roots. The number one way you can add to maximizing living roots in the normal agronomic ecosystems of our cropland systems, whether that be a 2,000 acre grass seed field operation or a 3-acre market garden is by cover cropping. Cover crops are amazing. They hit not just this living roots principle, they also hit maximizing diversity and keeping soil covered. So what is a cover crop going to do? It's going to extend the season, the length of time in which there's a plant growing in the soil that is capturing carbon and energy from the sun and pumping it into the soil. And depending on the cover crop you choose, it has a different root architecture. It has, if it's a legume, then it's going to fix nitrogen, which is going to increase your nutrient cycling. In Western Oregon, we have very few times a year that we actually get to biological zero, where biological activity is not happening in our soils, maybe just on a couple coldest days of the year. The rest of the year, stuff is growing. I mean, it's not as much when it's winter, but it's still growing. So when we think about cover cropping, it's all about keeping that soil food web fed throughout the whole year. When you leave something fallow, it's basically like you think of the soil food web as your livestock, and you have to feed them all winter. It's like if you have a flock of sheep and you go out there and you're like, okay, well, guys, it's November, so I'm going to go now and not see you till spring. No, you have to feed them all winter. Same with microorganisms. You have to do whatever you can to feed them along the way. Now, cover cropping it's not so much a management practice, it's a lifestyle. You really have to think about what you want your cover crop to do. Do you want it to provide erosion control? Do you want it to provide weed suppression? Do you want it to suck up nitrogen? Do you want it to provide nitrogen? There's all these different functions and choices what you want your cover crop to do. And you have to think about, okay, where can I get the seeds? Do I want a diverse cover crop mix? What am I going to do with the cover crop once it's grown? Do I have the capacity to terminate my cover crop, or do I want it to winter kill? There's all these things to consider, but fortunately there's so many tools and resources out there helping you to be able to figure out what's the best cover crop for you and how to think about how to fit cover cropping into your system. The next we have maximizing diversity. So I talked about how plant roots capture that energy through photosynthesis and pump carbon and energy into the soil ecosystem, into that soil food web. Well, funnily enough, and fantastic for us, each plant has a different flavor of stuff that pumps down into the soil. So you're going to get a different chemical composition of exudates in a corn or a brassica or a grass field or a flower. Just different plants pump different stuff into the soil, different flavors of those polysaccharide sugars. And different microorganisms outcompete each other for the flavor that they do the best with. And that's why when you have a monocrop, you have corn after corn after corn, or wheat after wheat after wheat, in those underground soil food webs, you're only getting one flavor. And so you self-select for a suite of microorganisms that just do really well with that particular flavor of exudate. And that shifts the entire population of your soil food web. But if you get diversity above ground and you're able to have lots of different types of plants growing in time and space, then you get lots of different flavors down there, and you get a lot of different flavors you start to get biodiversity in the soil food web. And you need that biodiversity in the soil food web so you can break disease pest cycles, to increase nutrient cycling, reduce weeds, increase predator species. There's nematodes that eat bad bacteria. Not all the nematodes are bad, so you want to have a nice diversity to get those kind of nematodes. And I say time and space because when you think about crop rotation, you can grow diversity at the same time with companion planting or relay cropping. Relay cropping is when you start the next crop before you've harvested your cash crop, so that you have, sometimes in shorter seasons, there's just not enough time to get something in. So if you put something in before you've harvested, then by the time you harvested, that's established and it's growing. That's relay cropping. Companion planting is having diversity in space. You also can have diversity in time as you rotate crops. So you're taking your different plant groups and you're moving them across beds. Now, another way to incorporate diversity, because there are some things you'll read about how the fifth soil health principle is incorporate livestock. So whatever, it can be its own standalone principle. In this case, I've decided to put it in maximizing biodiversity, because if you add livestock to a farm management equation, you're getting a lot of things. You're getting the nutrient cycling that happens in the body of the animal, and then you get its, manure as it goes along. I just put chickens here because most of the time social audiences tend to be small scale producers. But this could be, we've got folks in Eastern Oregon that will grow cover crop and then graze under their center pivots and then they don't have to do one winter feed, and they just put a lot of gain on their animals, and it's a win-win all around. So adding diversity can be with livestock, it can be with adding different things growing at different times of the year or at the same time that have different root architectures and different properties. So that's how you feed the soil, those two things. Now we want to protect our soil. And we want to protect our soil by maximizing soil cover. And this 100% goes down to whatever you can do so that you don't have bare soil. Soil is amazing. It's this vast, vibrant, robust ecosystem that you just never want to see it. It just always should be under something. And that under something could be a mulch, it could be compost, it could be a cover crop again, it could be a cash crop that you have relay crop something into. You just don't want to see your soil because you really want to think about wind and water and rain or irrigation, and the energy when wind blows across bare soil, or the energy of a raindrop as it hits that soil surface. If you don't have something between the soil surface and that raindrop falling at terminal velocity to cushion it and dissipate that energy, then that raindrop hits the bare soil. And if you don't have good aggregate stability, and a soil can only take a beating so far, even with good aggregate stability, particles, sand, silt, and clays will start to shatter. And they'll shatter, and then they'll fill in all of the pores, and you get a crust. And then when the water hits that crust, then you get erosion. So really maximizing soil cover is all about reducing the energy and potential for erosion. And when you reduce erosion, you're reducing nutrient loss because your nutrients aren't getting carried away in the soil particles that wash or blow away. It's maintaining soil organic matter. It's creating a kind of shelter so you're not getting a lot of evaporation. So if you get water into the soil and it drains, that the water you want to hold to be available for your plant sticks around. And that's also really important for buffering temperatures. You can have a 30, 40-degree swing between a shaded under the canopy of a plant and the bare soil between the rows. And microorganisms, after a certain point, if it gets too hot, they just stop functioning. And then it doesn't matter how much carbon you've got there. If it's too hot, they're not going to do anything with it. So we want to minimize disturbance. We're going to protect our soils by minimizing disturbance. Soils, depending, each soil has a different strength, how susceptible it is to disturbance factors. Typically, the way that we disturb soils is by machinery and tractors and tillage. This is a cool picture of the Oregon Trail. So that was a disturbance. That's still there today. It got compacted in the rangeland, and you can still see it. Those ecosystems don't have a lot of carbon cycling. It has carbon cycling, it just happens slower than you have in places that have more rain. So the reason we want to minimize disturbance is we want to maintain our soil structure. You see in this kind of schematic here, good soil structure with nice roots, plenty of time for water to get in. And then if you are tilling, what you get is a pan where that structure gets collapsed, all those spaces in soil, because life happens in soil. Nutrient cycling happens in soil. Water storage happens in soil. All of that cool stuff happens in soil in the places where the soil is not. It's in the empty space. It's in the big pores and the little pores, the teeny tiny pores. It's in the oceans and the lakes and the cavities. And you need to have that space. That's where the air is, and all that life is on the edges and the surfaces of the space. And if you disturb soil, you crush the space. If you don't have space, then you don't have a way for life to happen and for habitat to be there. And if you're not adding organic matter to your system, what do those microorganisms do? You start eating the sugars that are pasting their walls together. You start eating the carbon that's there. And so it all just breaks down in sugars. So when you disturb, you really got to think about, how do I keep my stable aggregates? And so I call it mindful disturbance, because it's very difficult to be an agricultural producer without any disturbance at all. It's almost easier for the guys that have the, 3,000 acre wheat fallow no-till system in the Columbia Plateau. That's easier to not disturb those systems than maybe in your home garden or your 5-acre market garden or your vegetable production, or maybe you're growing potatoes. Harvesting potatoes is a disturbance activity. So you got to think about, okay, I want to minimize disturbance. So I'm going to think about, what tool am I using? How deep is my tool going? How often am I disturbing the soil? Am I going to use this yellow box thing because I have a tractor as a spader that's just going to cut in and kind of lift and churn, versus a rototiller, which is going to pulverize? So it's really all about how you can space disturbance out. Do you have the capacity in the room in your operation to maybe go in until 1 year, but then it gets a whole full year of a cover crop because you moved over to the next location? So you can move your disturbance over time around your space. So I'm not saying don't disturb your soil. I'm saying think about what you're doing when you disturb your soil. Think about the water content when you go in there with machinery. Think about high traffic areas. Can you concentrate your traffic areas to the same place so that you're not moving those potential heavy compaction zones across the entire landscape? So it's just about being mindful about how you disturb. So these principles of soil health, the diversity, keeping it covered, living root, having disturbance, how do we think about applying these to the systems that we work in? So I always like to, everybody has what's going to work for them. Everybody has the capacity and the scale at which they're working and the opportunities to address these different soil health principles. So it's not about waking up one day and implementing a full-scale soil health management system. That is not the expectation. The expectation is you look at your management system, or if you're an ag professional and you're helping people to make management decisions or providing guidance and resources, have a conversation with them where you can look at, okay, I'm going to look at your vegetable production system and say, all right, I've got 5 acres, I'm doing a market garden, I have beds, and I am great at keeping my soil covered because I plant a winter cover crop and my soil is covered the whole year until I get ready to plant the next year. But I don't have a living root that whole time because I want my soil, my cover crop winter killed, because it's easier for me to handle the biomass if it winter killed. And then you think, okay, so I got it covered. We're getting pretty good at living roots, but I don't have a lot of diversity because it's just a single species cover crop. That might be a time where I'm going to try something new. I'm going to try an Austrian pea, and this time I'm going to try adding a barley to it to get a diverse root architecture under the ground. But man, disturbance, I just don't have the time or capacity or the equipment to not rototill to get my stuff in when I need to get it in. So it's all about just the scale you're working, the management capacity you have, and really at the end of the day, every little step is worth it. Looking out, I challenge you all who are land managers or who are working with people who manage the land, that every time you go out and you think about a farming system or production system, put it through the lens of soil health. All right, what are we doing in the system? Are there ways that we can, minimize our disturbance? Are there ways that we can get a shoulder cover crop established? Do we have the water to be able to do that? Or am I trying dryland farming practices where I have to just make sure I do a relay crop? And there's not going to be one single recipe for success. It's going to be about looking at each individual person's operation and seeing where are those places I can try something. It's worth it, and you can do it, and the biology is there. With that, I'm done. I'm going to try turning on my camera again. My email address is there. I will also put it in the chat. Oh, sorry, everyone. I'll put my email address in the chat as well. I apologize for any audio or visual challenges. I understand that it's part of the Zoom world. Even though I'm at the office alone, I'm sure the network is probably trying to update everything, and that's taking up bandwidth. So that's me. Any questions?
Thank you, Cory. We do have some questions.
Cool.
The first one that you can address hopefully, native pollinators need bare soil for nesting.
Oh yeah, some of them do. So you would just want to work that, if one of your objectives is native pollinators like ground bees and stuff, then obviously work that into your system. I would say that it's almost impossible in a lot of scenarios where there's a lot of management to have 100% cover. Well, Western Oregon weeds will kind of get in there, but I wouldn't worry too much about it. I think if you probably don't need to manage for bare ground unless there's something very specific, that a specific species that you're going for.
Great. So the next question, which you did address, I believe, a bit about when you're talking about minimizing disturbance. The question is, what about when you turn in your cover crops? Is that not tilling?
Yeah, so that's the challenge. And it all depends on scale and the kind of equipment you have. If you have access to equipment that does lower disturbance than like a rototiller, you can actually get away with less disturbance, but still getting the benefits of turning the soil over. The other thing is if you think that you're going to have like a huge amount of biomass, like choose a cover crop that you weren't going to end up with this huge amount of biomass so that you don't have to put as much energy into it to turn it over. So it's kind of this dance between, I know I have to do disturbance to get my organic matter in the soil, but what machinery or what access do I have to disturb it just enough? Just, you might have an acre that you're growing, but you're doing rows. Can you just do the high disturbance and exactly where the plant is going to be? If they're only putting a seed in something that's an inch, can you only disturb an inch instead of a foot? It's all about what kind of machinery and what you have there. It's tricky. I get that question every single time. And it's really an individual answer based on what people have access to.
Great. Okay, the next question. What about cover crops for Northwest Native Hillside restoration projects?
Well, does the cover crop need to be native if it's a native hillside restoration project? I'd have to know a little bit more about, maybe in the chat, if you don't mind. I mean, if it's a hillside, my first thing is you're going to want a deep rooted, like a ryegrass or something like that. That's going to be an ant that's not going to winter kill. That's going to stay there. But if you're doing a restoration project and you're trying to like get shrubs and forbs to grow, that gets more complicated because then you have to do that a grass is going to outcompete those. So I'd have to know a little bit more. I tell people, like, people ask me all the time, what's a good cover crop? And I'm like, okay, grab a cup of coffee and let's sit down for 4 hours because I need to know your lifestyle to know like what a good recommendation for a cover crop is, because there's a lot of factors that go into what your objectives are and what you can manage and what you can afford for seed and all that kind of stuff. So It's a big question.
Mm-hmm. So next question, is weed better than bare soil? Are weeds better than bare soil?
I would say yes. People would disagree. I actually have, it's a paradigm shift. I've actually gone out on tours with landowners in the Willamette Valley and they're like, yeah, my neighbors think my field looks trashy, but what I see is a big diversity of different cover crops that I didn't have to pay for. So you do have to be mindful though, because depending on where you are and what weeds there are, we don't want invasive weeds. We don't want weeds that are going to compete with the genetic integrity of our crops. So you do have to be a good neighbor, but I would take a weedy field over a bare soil for the erosion protection any day. The better choice would be putting something out there that you want. That's going to be helpful and build soils, but from just a protection standpoint, anything is better than bare.
Great. Is there ever a benefit in not rotating? This person is thinking in a vineyard and growing certain cover crops in that crop that is not able to be rotated.
Oh yeah, so in vineyard systems, and you probably are someone who knows more about vineyards than I do, the question asker, but I know that they only harvest every other row. They only have to put the equipment down every other row to harvest. So a lot of vineyards in the off row will put in pollinator habitats or a mixed species, diverse perennial cover crop, something that's not going to die, that will, over time they might have to reseed if they want a lot of diversity, but for sure, there's no problem in our perennial systems. It's a great place in the orchards in Hood River, those trees and vineyards or hops or hazelnuts, there's roots aren't in that 2-foot space that the plant physically is in. Those roots are going all the way into those alleys. So whatever you can do to have a vibrant soil food web in the alleyways, it's great.
Cool. This question is about your presentation. Did slide 31 say minimize living roots in the green print?
Oh, look. $35, did you say?
31.
I have maximize living roots everywhere that I'm seeing it.
Okay, great.
I might have just said living roots. So anyway.
Next one, is there a hierarchy of a good and bad cover crop?
Yeah, depending on what you want to do. And that's where cover cropping is the challenge. A bad cover crop for you might be the perfect cover crop for somebody else. And so that's where you really have to think about what you want your cover crop to do. Again, do you want it to stop erosion, suppress weeds, scavenge nitrogen, add nitrogen, provide pollinator habitat, but not too much because you want all the pollinators, it all, and then just like, okay, are you doing a cool season cover crop or are you doing a warm season cover crop? So there's a whole spectrum of things you have to think through when you're figuring that out.
Okay. Next question, what are good ideas for very low ground cover below flowers and smaller plants to maximize living ground cover?
Yeah, so that depends. There's a lot of native ground covers that are just sold as ground covers if you just have a space, like from a landscaping perspective that you want a ground cover. If you're talking more of like an agronomic ground cover, then you're talking about there's a lot of clovers, red clover, white clovers that have different architectures. There's some clovers that grow low and are perennial, and some that are annual and grow higher. So it kind of depends on if you're talking about like a landscaping space that you want ground cover versus more of an agronomic ground cover. Because I know like vineyards will do like a clover in their alleyways too.
Okay. Do sunflowers have growth inhibitor that they exude, maybe just in the seed holes?
I'd have to look that one up. I'm not familiar with exactly what sunflowers do. I know I've seen sunflower cover crops, but then it's like usually just one, so they're not inhibiting each other. I'd have to look it up, but that is one consideration when you're looking at novel cover crops. Is it going to have some allelopathic issues for the cash crop that you want to put in after it? You can get around a lot of that. I mean, people use mustard crops as biofumigants, but then they have to have a space between them when the mustard crop is terminated and before they try and plant anything that they want to grow. There has to be a lag there. So the biofumigant is done and then the next crop can grow.
Great. Next question, how do you plant cover crops on small acreages, 1 to 2 acres, without having seeding machines?
Oh, well, so that all depends on, how much seed you can have. You could walk with, they have those belly grinders that can seed if you want to spin that. So people, I've seen them, they just put on like a backpack and it's got a crank and you fill that thing up with seed and you just walk your acre or 2 acres and you aerial broadcast, and you don't put the seed in the ground. It's just top dressed. So, that works when you have some kind of way that the seed's going to get to the soil contact. And some cover crops are better at germinating that way than others. So that is possible. You don't have to till seeds in. There's a lot of cover crops that will go well just with, spinning.
Okay. Do you have thoughts on no-dig strategies for urban small veggie gardens?
Well, for urban small veggie gardens, one thing about small gardens, like backyard gardens, is you have labor because it's usually just you and your family or your friends and the shovel. So you can actually get away with some just hands-on manipulation. You can mow that thing with your lawnmower and then just disturb the place you want to put the seeds if you want to get that technical with it. The other thing is, you know, I've talked to my colleagues at Oregon State University, Nick Andrews, for example, he and I have done presentations and he will say, you know, you can make up for a lot of your sins of your tillage by a good cover crop afterwards. So you can do some disturbance in these systems if you have the idea of where you're going to put that organic matter in that you might have broken up. Now, the challenge with that is that not all carbon is created equal in the soil ecosystem. You've got really dead stuff, kind of dead stuff, living stuff, and carbon exists on a spectrum. And we talk about carbon sequestration, the amount of carbon that's stored and the turnover rates, that all exists on the spectrum. So when you start tilling, but you're cover cropping to get the carbon back in there, your total carbon might be staying the same, but the balance of your carbon across that spectrum might be shifting. And that might be fine for what you're trying to do from a production standpoint. But from a urban, like in my home garden, you know, I just take my shovel and I kind of just turn it all over so it's still got all that structure, but then I've got a spot to put my seeds. So it just depends on how strong you are.
Okay. Do you have any experience with adding biofungicides? I might pronounce this very incorrectly.
Yeah, I can read it. Yep.
Can you? Okay.
Oh, I personally haven't used a lot of biofungicides. My question would be, did it work? Did you see a change? There's a lot of, one of the things about the whole industry around soil health is you can buy a lot of bugs in the jug, but there's not a lot of regulation. So there's not a certifying standard board or something that says that when you bought that biofumigant, that's the efficacy that it says on the bottle is the efficacy that you're really going to get. So that's one of the challenges when looking at some of the supplements and amendments that are organic and labeled as biofumigants, or, you know, buy a jug of mycorrhizal fungi or stuff. You know, there's just not a lot of industry standardization for this.
Okay. Another one about cover cropping. This one says cover cropping often requires tilling. How about mulch as an alternative?
Yeah, mulch is great. The nice thing about cover crops is you get the living root, but if mulching is what you can do and that's going to get organic matter in there, great.
Cool. Do you have native cover crops that you recommend for this area?
No, I'd have to think about that one and go to some experts. I typically, when we think of cover cropping, it's an agronomic crop. We have native plants that produce cover, but you know, usually when you want a cover crop, you want something that's going to germinate when you want fast and do its thing. So I'd have to look that one up.
Okay. Do you have a recommendation on how the the person who asked the question can get that information?
Oh yeah, I would go to, well, I'm gonna be honest, I have never heard of a native cover crop that people use agronomically as a cover crop, but there might be native species that could mimic that. If that person catches my email, they can email me that and I can put them in touch with someone who would know that answer.
Okay, great. Okay, next question about cover crops. Can you just cut a cover crop and leave it in place as mulch?
Yep, totally. It's called green manure.
This is a question about the demo. It was helpful, but seemed counterintuitive since it seems water wasn't infiltrating that soil well.
It is. This one that didn't shatter, if I took it out and I opened it up, it would be this beautiful saturated soil pad. If I took it out and let it drain out, all that water had gone in and it's going to be stored in there. I've had people make me do that because like there's a rock in there or something, but nope, this thing is gone. This thing is dead. This is like eroding away down the hill. Bye-bye all your fertilizer. Bye-bye all your organisms. Shattered, eroding soil. The water doesn't go into it. It just busts it up. This one, the water is in there. There's actually air bubbles all on the surface of this because the air is pushed out of the pores because the water is gone in.
Great. We have a question now about equipment, broad fork versus tiller.
Whew. I'd have to look at what tiller and what broad fork. there's just, it's whatever's gonna, work for you, that's gonna disturb just enough.
Great. So we're actually at time, but perhaps we can squeeze in one more quick one. How do I improve clay soils to improve water permeability?
How can I say that one again?
How can I improve clay soil?
Yeah, so you get what you get. You get what you bought. You have a clay soil. That clay soil is really good at doing clay soil stuff. Now, if that clay soil has been managed in a way that has compacted it, that's tough. Really, the best thing to do, it depends on the size of the space, what you're trying to do. So let's say you have an acre of a clay soil and you want to grow a big, huge garden. And that clay soil used to be a pasture, so it's really compacted. In that situation, I would recommend a big intervention to set you up for long-term success. What I mean by that is go in with your rototiller, break up that clay soil, but immediately go into the high fiber root dense cover crop. Is the best way and the only way to increase infiltration on a clay soil is add organic matter. The other thing you need to consider if you have a clay soil is what is your water table? Because you just might naturally have a high water table. And the only way to get rid of a high water table is to put drainage infrastructure. And that's like plastic tile drains, which depending on your scale, again, home garden versus 5-10 acres, because you basically have a wetland. So that soil is doing what it's supposed to do from a wetland perspective, but it's just not great for growing plants that you might want to eat, like it grows wetland plants, just not agronomic plants. So like it all depends on how much of that clay soil, how that's been managed in the past, how much disturbance that has had in the past. You can't like mix sand in to get you a loamy texture of clay soil. What you do, if you did that, you'd mix cement. So it really just depends on how big of a thing you've got going on.
Great. Well, we have run out of time. Thank you so much, Cory, for all of this wonderful information. Thank you to all of the participants. We hope to see you at future sessions this month. And you can access the recording in about a week on Tualatin SWCD's registration page on the event page. So thank you very much. Have a good night.
Thanks for having me.